A couple episodes back, we had this harebrained idea to try and build a replica of the 555 timer out of vacuum tubes. And this was the result. It was 18 vacuum tubes on a very large home-cut PCB with some sheet metal legs spot welded to nails. It was ridiculous in every sense of the word. And in that episode, I had expressed some interest in potentially building that into a kit that could become available for people to potentially purchase and build themselves. And this is the result of those efforts. And I would love to show this off, except that currently it doesn't work. You'll notice that we're down to about 12 tubes now. So I've made some pretty radical changes and, well, those radical changes have growing pains, and so we're still going through the revision of this. But we'll take a closer look at it on the bench and point out some of the major changes that have gone on. But because this doesn't work, and this is now revision B, I'm currently building and waiting on revision C, I'm in this interesting spot where I'm waiting on boards to be delivered, but they're not here yet. So I'm not really one to sit on my hands and do nothing while I'm waiting on parts. So naturally, I decided to start another project, only I wanted this one to be a little smaller. The 555 timer is one of the most popular ICs in history. But a close second behind it is the 741 Operational Amplifier. Just like the 555, it is an 8-pin DIP form factor, and it looks identical as far as the actual IC chip goes. But the insides are quite a bit different, and actually there's a whole lot less going on inside of the 741. And so I figured that would be a cool project to tackle while we wait on PC boards to arrive from overseas. And so let's hop over to the bench. We'll take a quick look at the 555 kit here, give you guys a short little update on how that's going, and then we'll take a look at what I decided to build based around the 741 Operational Amplifier. So let's hop over there and get started. All right, on the right we have my original 555 timer that I designed a couple episodes back, and on the left we've got revision A of the kit version. But as I said, this version doesn't work, and that's due to some of the major changes that I made. And I mean, I guess so far the obvious major change is that there's a lot fewer tubes. The original version used 18 tubes and the new version uses 12 tubes, but those 12 tubes don't quite work. I'm gonna have to bump that up a little bit. So I'm gonna have to bump up to 14 tubes. So there's gonna be a slight change in the topology here when the next revision comes. But aside from that, the next biggest difference that you'll notice is that it's shaped a lot differently. It sits a lot taller on these very cool aluminum legs. And that's because the first version I built just based around the type of PC board that I had available in that size. But this version on the left here is actually a scale replica of the original 555. So the dimensions all match from length, width, to even the height of the legs. And so that is just like an actual 555 was scaled up, which I think is really pretty cool. Now the legs are these really cool laser cut aluminum legs, and they're a little difficult to solder on. You have to get them really hot, but I was able to get them to solder on pretty well, and they're all really sturdy. So it gives this whole piece a pretty robust feeling, and it allows you to make connections pretty easily with alligator clips onto the legs. But at the end of the day, it still doesn't work. So while waiting on the new boards for this to arrive, I couldn't help but try to build something else. So let's take a look at what the 741 is, take a look at our design for it, and then maybe we'll hop out to the mill and cut up some circuit boards for it. All right, so here's the TI datasheet for the LM741, which is what we're trying to build a replica of. And we can see it's just really an operational amplifier. And well, we have a little bit of experience building operational amplifiers because we built a copy of the old Philbrick K2W operational amplifier for use in the 555 timer. And so here is our updated schematic that we're going to use for this. It's really pretty similar to what we built for the 555 timer, except there's been some pretty dramatic changes in resistor values. So for our differential pair here on the left, we're using a 220,000 ohm resistor for the plate on one of them. And if we look at the next three amplifier stages, we can see that all three of these use 220,000 ohm resistors for the plate. Now, the reason that I stepped up to such a massive resistor for the plate is because we're running at such a low voltage that I'm trying to extract as much gain as possible out of each amplifier stage. Now, whenever the plate resistor increases in value, the amount of current that the plate can supply decreases proportionally. So we need much, much larger resistors for our resistor divider network into the grid so that we don't end up pulling the plate value too low. Now you'll notice something interesting about these voltage divider resistors is that we have two 470Ks and then in between them we have a 500K potentiometers. And the reasoning behind this 500K potentiometer is to adjust for using different tubes. All of my designs are based around the 6AU6, but I wanted to be able to use other 7-pin sharp cutoff pentodes that are pin compatible in this circuit, such as the 6CB6 or the 6DT6. But each tube has different characteristics, and so the negative bias on the grid is going to have to be adjusted appropriately. And so that's what this potentiometer is doing. It's giving us the ability to change out to a totally different tube and be able to get it working by just adjusting the potentiometer values. And then of course here at the end we've got a cathode follower buffer to buffer the output, and coming off of that output we have a 820,000 ohm resistor that goes to the cathode of the previous gain stage, and we have a small capacitor that goes to the grid of the previous gain stage. And these are feedback to prevent unwanted oscillations from occurring. Now, depending on what frequency you're running at, the value of this capacitor is going to change pretty dramatically. So we're going to have to think up of a solution of how to change this capacitor value without desoldering and resoldering stuff. But I have a couple ideas about how to tackle that. So let's take a look at the actual PCB layout that I came up with. Now, like the 555 kit version that I was working on, I really wanted to do something about the legs. And I really like the laser cut aluminum that I'm using for the large 555 timer kit. But I wanted something that I could produce here. I have to order those laser cut pieces. I don't have a laser cutting machine. So I had this idea of cutting the legs out of PCB. So I have a bunch of single-sided PCB out there. So I was thinking I could just cut out that copper-clad PCB and not cut any traces into it, and then solder that PCB to the opening that's going to be in the primary board here. So we have a design I'm pretty happy with. Let's fire up the mill and cut out some PC boards. All right, and here we go. And I absolutely love the way this thing turned out. It looks amazing. And if we compare it to the 555 timer kit that we are working on, Well, we can see that there's a massive size difference here. It literally looks like this little one up front is the offspring of the big one behind it. It's kind of hilarious, but we can see a lot of the design elements that I learned the hard way with the big version making their way into the little version, particularly the legs. I love these aluminum legs on the big version here, but these PC board legs on the little version were so much easier to solder in, and they look amazing. Oh, they're all proportioned just right. This thing is awesome. I couldn't be happier with it. So let's give this thing a test, and we can just hook some alligator clips up to the legs here. All right. Let's see here. Let's put this on. All right. Well. Oh, okay. Okay. I mean that's not graceful. All right. Let's try again. Okay. All right, so the legs are much closer together than they are in the big version, which makes it a lot harder to get these alligator clips in place here. Let me see if I can get one more on there. Okay, well that's the front half, and well now I've got this this big mess of alligator clips here. All right, well, I'm not happy with that. There's got to be a better way to do this. So I think let's hop back out to the garage and see if we can't build something that makes this unnecessary. All right, I think I've got just about everything set up right here. I've got my HP 200 CD wide range oscillator over here to give me a sine wave. If you're curious about this particular HP oscillator, I actually have a full video where we take a look at the inside of it. It's a really interesting video. I'll put the link in the description below. But it's giving us a sine wave out that we're going to use as our input. And then to test our operational amplifier here, we're actually just going to set it up as a negative feedback amplifier. So essentially we have our sine wave coming into the negative input through a 10,000 ohm resistor. And then we have in this case, I'm using a 22,000 ohm resistor as our negative feedback. And the ratio of this resistor versus this resistor should give us our gain rate. So 22,000 and 10,000 should give us a gain of 2.2. So if we have a 1 volt peak to peak sine wave coming in, we should get a 2.2 volt peak to peak sine wave coming out. Now the non-inverting input is hooked up to a 50,000 ohm potentiometer that goes between 24 volts and ground, and that's because this operational amplifier doesn't go from a negative voltage to a positive voltage. It goes from a positive voltage to a more positive voltage. And so we're going to adjust the offset using this 50,000 ohm potentiometer to allow it all to operate correctly. So we've got our scope set up, we've got the largest IC socket in the world, And on our breadboard here, we've got essentially exactly this set up. And let me tell you, these little jumper cables make it so much easier to hook everything up. But I think it's time to give this a test. So there's pin 1. Let's go ahead and plug this thing in and see what happens. Everything should start warming up. There we go. Now we're starting to get a little bit of a stable waveform. As it warms up, it's kind of moving around a little bit. Okay, so coming in from our oscillator here, you can see that we essentially have 1 volt peak to peak on our input. And if we look at the output, which is the yellow trace here, it's reading well, it's kind of bouncing around. It looks like it's bouncing between 2.1 to 2.4. That's pretty close to a gain of 2.2. That's awesome. That's working really well. So let's change out this 22,000 ohm with a 33,000 ohm and see if we can't get a little more gain out of it. All right, there we go. Yeah, we can see, again, we're right at 1 volt on the input here. And on the output, we're getting about 3.1 volts. We should be getting about 3.3 volts. So we're starting to drift a little away. But that's still surprisingly close. We'll see if adjusting, oh yeah, if I adjust the offset enough, I get a little more out of it. Yeah, so if I move our bias up and down a little bit, I can kind of change what this is sitting at, because now I'm seeing 3.2 volts, which is a lot closer to what we should be getting out of it. Actually, that's surprisingly accurate. I'm really happy with that. All right, well, let's push it a little further, because we're starting to see that it's diverging a little bit with a 33,000 ohm. Let's put 100,000 ohm in there. All right, there we go. That looks pretty stable, but we can start to see that we're actually starting to drift quite a bit. So I'm seeing about 8.6 volts, and we should theoretically be seeing 10 volts out of this. So that tells us that it's about 90% accurate, which is not perfect, but really that's not that bad. I'm pretty happy with that. So that's awesome, and I might be able to get a little more accuracy out of it by adjusting these control potentiometers up here, or even by changing the tubes out to a different type. So the fact that there's so much adjustability in this means that you can really fine-tune it to however you want. But at the end of the day, we always knew that a low-voltage vacuum tube replica of a 741 operational amplifier was never going to be perfectly accurate, but that's a level of accuracy that I'm pretty happy with. Now we're sitting at an incredibly low frequency. The oscillator here is at just about 100 hertz. So if I speed this up a bit, you can see now we're running into an issue. So that's just about 200 hertz. And well, first of all, our peak to peak has dropped considerably down to 7.2 volts, and we're no longer a sine wave. We're now a triangle wave. And so the reason that this is happening is our feedback capacitor is too large. So we need to change that feedback capacitor out for something a little smaller. And so I put the capacitor into a little socket so we can pop it out and pop a different one in. There we go. That's a smaller capacitor, and you can see that at essentially 195 hertz now, we're back to a nice shaped sine wave pattern and back up to 8.6 volts. So we're pretty much right back to where we were. And so being able to hot swap this capacitor and having these tuning potentiometers allows this 741 OpAmp replica to really be kind of fine-tuned to however you want to use it. Man, this is super cool. And all of that in a package that you can just unplug, unplug or plug right back in. How cool is that? I am just absolutely blown away with how well this came out. I love the fact that I now have a socket for it. It works really well. It's not perfect, but we never expected it to be perfect. If you guys are interested in seeing this one become a kit as well, definitely let me know in the comments, and I'll get started on designing this up as a kit that could be potentially made available alongside the 555 timer kit. But in the meantime, thank you guys so much for watching. I am just blown away and could not be happier with how this turned out. So I'm going to keep playing with this, keep trying to figure out all the interesting little quirks, maybe try some different tubes in it. But Hopefully, I'll see you all in the next episode.